Okay, this is question 14 on 2018 additional maths paper from WJC, and this is a first principles question. So with first principles, I asked you to find dy by dx, but my preference is to call it f of x instead of y, and then find f prime, or the derivative. You can still call it dy by dx if you really want to, it doesn't make a difference, but I prefer to write it as f of x, and then f of x plus h is a little bit further along, which is, instead of putting, when a function of x, you put in x squared and then 13 lots of x. When it's x plus h, is going to be x plus h all squared plus 13 lots of x plus h. Okay, so that's the difference. So x plus h all squared plus 13 lots of x plus h. And if I expand these brackets, the first is a binomial squared. So this is a quick one that you need to be able to do. You can square the first term. So the first term is x. If I square that, I get x squared. I double the product. Well, the product is multiplying those two together, which is hx. Double it is 2hx. And then I square the second term, which is h squared. And then expanding that second bracket is plus 13x plus 13h. Okay, now I'm going to start looking at using the terms in the formula, which is f of x plus h minus f of x all over h. Now notice at the moment I'm not talking about limits at all. Some teachers will use the limits all the way through. It's absolutely fine. It's just my preference that I did the limit right at the end. So this becomes f of x plus h is x squared plus 2hx plus h squared plus 13x plus 13h. And I need to take away all of f of x. So my f of x is x squared plus 13x. And that's all divided by h. So what we should be able to do is cancel out everything in the bracket. So I've got an x squared, take away x squared. That's going to cancel. And then I have a 13x, take away 13x. So that's going to cancel as well, which leaves me with 2hx plus h squared plus 13h all over h. Now, there's different steps from this point, but what I like to do is to take h out as a factor on the top. So I get h lots of 2x plus h plus 13, and that's all over h. And then we can cancel out these h, because the top is multiplied by h and then divided by h. So they will cancel out and leave me with 2x plus h plus 13. Okay, now at this stage I can use my limits. So I can say f prime of x, or if you prefer, dy by dx, same thing, is equal to the limit as what happens as h gets smaller and smaller and goes to 0 of this expression I've just worked out, 2x plus h plus 13. Well, what's going to happen if h goes to 0? Well, the 2x isn't going to be affected at all because there's no h's involved in that. So that becomes 2x. The plus h is going to go to 0 because if h goes to 0, then this will go to 0. But the plus 13 at the end doesn't involve h, so that stays as it is. So my dy by dx, or my f prime, however you want to write it, is 2x plus 13. And you can check whether that's right, because you should know quickly that the derivative of x squared plus 13x is 2x plus 13. Well, that's how you get there.